will be which will be the okay, so which will be the structural design pattern. So when I'm talking about structural design pattern, so creational design pattern was all about creating the objects. So basically in structural design pattern, we will try to provide the different ways to create a class. Okay. So by using the inheritance and composition to create large objects from small objects. So basically what I'm trying to say here is, whenever we are talking about creational pattern, so it was all about creating the objects. But now when we talk about structural pattern, it is the way we provide different ways to create a class structure. Okay. So generally what we use here, we use inheritance and composition. Inheritance and composition to create a large object from small objects. So to give you a small recap of what exactly is inheritance and what exactly is composition, I have two examples for you. Okay, so let me take you to the Eclipse. Okay, so my software where I try to develop the programs. So to show you a simple example on composition and inheritance, I have two programs for you. So first of all, let us understand what exactly is inheritance by an example. So now if you look at this, okay, sorry, this is like, okay, so let me show you this. So this is inheritance basically. So now I have a class animal. I have a class animal. So just general example for that matter. So I have a class called animal. So animal which is containing private data, So this is again implementation of encapsulation. See, whenever I'm talking about design pattern, so we should never go away from object-oriented programming. Okay. So object-oriented programming must be kept in mind. So without object-oriented programming, so no design pattern can be applied. So private Boolean vegetarian. So vegetarian is a variable. Vegetarian is a variable with Boolean type. Eats is a string and number of legs int. So which will show you the number of legs. Okay. So which will store number of legs basically. So now I have a constructor. So which is a default constructor animal. And I have another constructor with parameters. Okay, so this concept is constructor overloading. I'll just try to give you the overview of all the concepts what we have used, because that will be like a review for all of you. Okay, animal. So what is this animal now? So animal is a constructor, and you have another constructor called animal. So which is going to have three parameters. What are those three parameters? The three parameters are veg, food, and legs. Okay. So basically these have to be passed from the runtime. Okay. So now what we are using, so we are going to have this value which is passed from the runtime. So that will be taken into vegetarian by using this keyword. So which will access the instance member of the class. So which will access the instance member of the class. Okay. So now I have a method. The method which will return a Boolean value. So what it will return? It will return a vegetarian. So it will return vegetarian variable. Okay. So now we also have a method called set vegetarian. So which will take up a Boolean value and it will return which will store the vegetarian. So this get eats, set eats, get number of legs, set number of legs. So this is all encapsulation for that matter. Okay, so we have three variables, and for those three variables, so we have used something like getter and setter methods. Okay, so now class cat. So this is exactly the inheritance. So what is it here? So cat is inherited from the class called animal. So cat is inherited from the class animal. So cat class is inherited from the class animal. Okay, so private string color again in the cat class. So in the cat class, so now inheritance means this vegetarian eats number of eats generally should come, but are as these are private, so they are not being taken into this, but definitely by the help of the methods we can take up those values. Okay, now string color. So string color again this is private, so that is not coming from any of the parents. So next cat constructor. Okay, so now boolean constructor cat is also taking veg food and legs and super veg food dot comma legs. So this again is another parameter with the color extra variable. Okay, so now we'll make the call. Okay, so we'll make the call. So where we have to make a call? So cat new cat false. So false milk 4 and black. So where this call exactly is going to this call exactly is going to here. So 77 line literally is making a call to line 56. Okay, so making a call to line 56. So with the veg being given as false, milk being given as food, 4 being given as legs, and black being given as color. Okay. Now if you observe here, so veg value will be taken as false, and food value will be taken as milk, number of legs, legs will be taken as 4, and this dot color. So this dot color will be set to black. Okay. Now, as it is making a super call, it is a super constructor call. So super constructor call will be made to the super class. So is the super class here? Super class is the animal class. So now I am getting a super call to here. Once I'm getting a super call to here, so what I'm taking with me, I'm taking veg, the value false, the value milk, and the value 4. So the call I'm getting down to here. And those values will be replaced onto this. So this dot vegetarian, this dot eats food, and all. Okay, fine. Now all that happened with the help of this particular call. So then what we are saying, cat is vegetarian. So where the call is going? The call is going to cat dot is vegetarian. So cat dot is vegetarian. What exactly? Where the method is available? The method is available in the parent is vegetarian. So return vegetarian. So what vegetarian contains? So vegetarian contains the value false. So generally here, what will be executed? False will get executed. Okay. Get eats. What exactly get eats is here? Get eats, cat dot get eats. So where does the call go here? Cat dot get eats. The call will go here. So get eats. So what it return? Return eats. So what is the eats value? Eats value is the milk. Eats value is the milk. Okay. So eats value is the milk. Okay. So now here you can check get number of legs. Where the get number of legs is going? Get number of legs is going here. So what is the number of legs will be taken? Number of legs will be taken as 4. And get color. So cat dot get color. So get color will not go into the parent because it is the method of the child class. So get color, return color. So what color will be returned? Color will be returned as white. So color will be returned as white. Okay. So here, so what we are saying? So we are saying number of legs is 4. Okay. And get color. Okay. So here we need to understand one more thing. So get color. So color, we are passing it over here. And when you say this dot color, okay, so this dot color white, so we are not making a call to this. So definitely color is going to be black. Okay. So let us run this and see how the code will execute and give us the answer. So now you can see black. So the color is black because the call went to the 4 parameterized constructor, not the 3 parameterized constructor. So if you make a call to 3 parameter constructor without giving the value black, so without giving the value black, so generally what happens? Okay, so let me so let me make all these calls once again so that we will have the idea of what exactly the change will come in the output. Okay. So cat, here I'll say cat 1. So here I can say cat 1. So here I will say, okay, so rat. So here I will not pass the value black. Means I'm making a call to this constructor, basically making a call to this constructor. Okay. So that's generally okay. So now get it. So here I'll say cat 1. Here I'll say cat 1. Here I'll say cat 1. So now here what changes you can see in the answer. So you can see here, false is right. So in the place of milk, you will get a rat. So number of legs 4 only I gave. Okay, so 4 only I gave. So get color white. So because white means so here. So here we have specified the value. So this is what generally mean by inheritance concept. So inheritance concept. Okay. So why we are looking at inheritance? Why what made us look at inheritance? Because our structural pattern provide different ways to create a class structure. For example, using inheritance and composition. So in order to know about the composition, so let me give you another example. So now here composition is like as has a relationship where inheritance is a relationship. Okay. So what it is? So it is an easier relation. So very important point this one. So inheritance is an is a relationship. Inheritance is a relationship. Okay, so is a relationship. So whenever I'm talking about this, so it is a relationship and this is a as a relationship. Okay. So so now if you look at the composition, so let us go from down. So let us go from down and see the calls. Okay, so that will be a good understanding of the program. Now, so we said shape new triangle. So we said shape new triangle. Okay, we said shape a new circle. Okay, so means what all we have created? We have created a triangle object, we have created a circle object, and we have created a drawing object. Okay, so now here if you observe, so we said add try one, add circle. So what we are doing here? We are creating the objects, and we are passing as an array list. So we are passing as an array list. So simply what we are doing here, we are creating the objects and getting that into the variables, of course object variables. And after creating the object variable, so we are adding it in drawing. So who is drawing here? So drawing is a class. So drawing is a class which is implementing the shape. What is shape here? Shape is an interface. Shape is an interface which is going to give us the draw method. Okay. So whenever somebody is implementing shape, they have to implement the draw method. They have to implement the draw method. Okay. So they have to implement the draw method. So here what we are doing? We are taking up drawing. So what is this drawing basically? So drawing is a class which is also implementing the shape, but what it is containing? It is containing a list. It is containing a list of shape type. So basically what we are trying to do here, so we are trying to add. So what we are trying to add here? So we are trying to add the shape as object. So what are the shape as object that we are adding? We are adding the shape as objects. So shape as objects are nothing but these objects. Okay. So these we are adding into the list. And then what we are going to do? So we are going to say draw red. So once we say draw red over here, once we say draw red over here, so draw red. So shape. So what are all the shapes? So what are the shapes that we have? So we have here, and we are filling that. sh.draw. So fill color. So we are filling the triangle with the color red, and then we are trying to fill the other ones with the color green. So if we run this, so we are going to have, so drawing red with and then triangle with color green. So what exactly is happening? So we are using the has a relationship. So here you can say drawing has a shape. So drawing has a shape. So in this way, we are applying the concept of composition. So this is all about inheritance and composition, just a kind of review of all the things that we already know, but maybe if you don't also, now that was a clear picture of how we can apply the inheritance and composition to our data value, to our program. Okay, so here the next point that we are going to understand is what are the different types of patterns that are available under this structural design pattern. Under the structural design pattern, we have 6 or 7 more important patterns. Under that, we are going to talk about 3 patterns. So the first pattern is adapter pattern, then the pattern is bridge pattern, then we are going to talk about the composite pattern. So the next available ones are proxy pattern, flyweight pattern, facade pattern, or and finally decorator pattern. Okay, so we are much more interested in the first 3 patterns: adapter pattern, bridge pattern, and a composite pattern. So now let's begin with the adapter pattern. So let's begin with the adapter pattern. So whenever I'm talking about adapter pattern here, so adapter pattern is all about uh, all about making two unrelated interfaces work together. So adapter pattern is nothing but a process where it will make the two unrelated interfaces work together. So unrelated interfaces in the sense, now let us understand. So basically we have to see here, if you observe, so in the previous section, so suppose if I'm saying shape and drawing, so shape and drawing, they are somewhere related kind of interface. But in this structural design pattern, adapter pattern, so what I'm going to say is, I'm going to say that I'm going to work with two unrelated interfaces. Okay, so two unrelated interfaces, and I will make them work together. I will make them work together. So that is what the main point under the adapter pattern. Okay, so now here if you observe, so this object, or we are going to create the object that will join the unrelated interfaces. So that will join the unrelated interfaces. So what we are going to do? So we are going to have an object that will join these two unrelated interfaces. Okay, so that basically is called as an adapter. So that basically is called as an adapter. So whenever I'm talking about adapter pattern is a pattern which will be making two unrelated interfaces working together. So if you look at a general real example, so we can take the mobile charger. So how the mobile charger is related to this? Okay, so basically mobile battery require 3 volts to charge, but the normal socket produces what? Produces 120 watts or 240 watts in India. Okay, so basically in India, so we have 240 watts, but in US kind of countries, so we have 120 watts. So what we require now? We require only 3 volts. We require only 3 volts. So, but if you directly charge with 240 volts or something, so it will be like burnt. So that is why we try to have an adapter. So we try to have an adapter. So adapter between the mobile charging point and the wall socket. Okay, so hope you understood. So what I'm trying to say, so we have 120 and or 240 basically. So let's say we are in India, so 240. So when I say 240, so but I require only 3 volts, So what will adapter do? So adapter will be helpful for giving giving the 3-volt charger by taking up the 240 volt. Okay, so what generally I mean to say here? So generally I mean to say that mobile charger works as an adapter. So that's the main issue. Okay, right. So first, what we have to do, we have to create two classes. Okay, so first, what we have to do, we have to create two classes, volt class and a socket class. Okay, so volt to measure the volts and socket producing constant volts of 120. So basically what we are trying to do, so we are trying to create two classes. Okay, so what we have to build now, we have to build an adapter that will produce 3 volts, 12 volts and 120 volts. So all this we will be seeing with the example. So we'll create an adapter interface. Okay, so basically, whenever I'm talking about this, okay, let me go to the example and then we'll come back here. So now let me go for the things. Okay, so as I've told you, so we are going to have a volt class. So what does the volt class say? Volt class will say that I will have a variable called volts, and I will have a constructor volt, and I will have get volts and set volts. So that is what I said. So we are going to use the composition. Okay, so we are going to use the composition. So we are going to use inheritance, and we are also going to use the concept of encapsulation, where we are using the get and set methods. Okay, so don't get away from OOP. So that's the main constraint that is required when you are understanding the design patterns. Okay, so generally what happens here, generally I'm creating a class volt. Okay, generally I'm creating a class volt, and this volt will contain a variable called volts, Of course, it will contain a constructor, which will take up a variable int v. So then if at all v is passed, so that will be passed on to volts. And get volts will return the volts, set volts will set the volts value into this particular variable. So this is all about the volt class. Okay, then look at the socket class. So look at the socket. So socket class is the class which is containing new volt of 120. So get volt. So it is going to contain a get volt. So get volts. Okay, so what it returns? It returns the volt class object. So what it returns? It returns new volt of 120 whenever it is called. Okay. So now we will have another interface, which is get socket and socket adapter. So what we have? Socket adapter. So what this socket adapter is going to do? Socket adapter is going to return volts upon using get 120 volts. So get 12 volt, get 3 volts. So what exactly is happening over here? We are going to use the socket adapter class interface. Okay. So where we are going to use this, we are going to use this. So these are the 3 preliminary classes required. So now going back to here. So we need to go for two-way adapter patterns. So what are those two-way adapter patterns that are required? One is okay, class adapter, and the other one is, so one is the class adapter and the other one is the object adapter. So what is the first one? First one is going to be a class adapter, and the second one is going to be an object adapter. So class adapter and the object adapter implementations we are going to look at. So basically what exactly this class adapter and object adapter are telling us. So class adapter uses Java inheritance, Okay. So, and whereas your object adapter uses the concept of composition, So whenever I'm talking about class adapter, so class adapter uses the Java inheritance, object adapter uses the Java composition. Okay. So now whenever I'm saying class adapter, concept of inheritance. Whenever I'm saying object adapter, concept of composition. Okay. So these two implementations are necessary for us. Okay, so then how I'm going to do that? So first of all, let us understand how we can go for the class adapter. Okay, so adapter design pattern, class adapter. Okay, so now let us see what are the things that are being taken up by socket class adapter. So here you can see socket class adapter implementation is extending the socket, and it is also extending, or it is also implementing the socket adapter. So generally, so it is implementing both socket and socket adapter. So what socket is? Socket is going to be this method, get volt method, and socket adapter is going to be these three methods. So socket adapter is going to be these three methods. So now we have a total of how many methods into the socket adapter implementation? We have get volt method from here, and we have 120 volt, get 12 volt, and get 3 volt from here. Okay, so those are the things that we have under the socket class adapter. Okay, so now I'm going to return get 120 volt. So get the volt. So this is the method again. So then again get 12 volts. So what I'm going to do? I'm going to use get volt. Okay, so converting. So now what I'm doing? I'm going to convert. So what I'm going to do? I'm going to convert. So how I'm going to convert? So when somebody is calling this, so what convert will do? So convert will make a call to convert volts. So what it return? It will give two values. What are those two values? The two values going to be V and 10. So V will be taken up into the volts, and 10 will be taken up into I. So what will happen now? V dot get volts. Okay, suppose somebody is saying V is 120. Somebody is saying V is 120. So get volt. So get volt means the call will uh, uh, the call will go to the get volt method. So where is the get volt method? So get volt method. So get volt method is, yeah. So it will go to get volt and get the value 120, because we are considering something like US time. Okay. So get volt. So what is happening here? Get volt. So once the get volt is coming, so let us go with the call later on, and then conversion happens, and then it will be converted by divided by I. Okay, so once again we'll look at that. Okay, so once this happens, okay, so object implementation, okay, so and then object adapter, which will be taking up the composition. So how the composition is? So private socket sock is equal to new socket. So we are creating the composition, means has a relationship. Previously it was a easy relationship. Now you can see it has a relationship. Okay, so convert total down. Okay, so now we will try to look at the calls made to these two classes. Okay, so now in order to look at the class, let me go for the adapter pattern. So let me go for the adapter pattern. And then under the adapter pattern, so you can see that. So under the adapter pattern, you can see that. So adapter pattern test. So under the adapter pattern, so this is the object adapter call, and this is the class adapter call. So both the calls are okay. So now always remember, we need to go to the main method first. So whenever we are calling, so we need to go to the main method. So once we go to the main method, where my call is going, so my call is going to the so my call is going to the test class adapter. So my call is going to the test class adapters. Once my call is going to the test class adapter, what is created here? So socket class adapter implementation is initialized. So what is initialized? Socket class adapter implementation is initialized. Okay. So this basically is initialized. Once it is initialized, so it will get the socket properties, it will get the socket adapter properties, and it will be helpful for taking all this. So once we are done, so what we are doing here, V3 is equal to get volt sock adapter comma 3. So get volt sock adapter comma 3. So get volt. Where this method call will go now? So this method call will go to the get volt. So where is the get volt here? So get volt. Okay, so get volt method. So where is the get volt method? Get volt method under the under this. So get volt method. So get volt. So what is the get volt? So get volt is getting us. So get volt is getting us. Or now, if you observe here. So what is the get volt we get for us? Get volt will get. So we'll take sock adapter comma 3. So what is the sock adapter? Sock adapter is the socket of, sorry, I think we need to look at this. Okay. So sock adapter is socket class adapter implementation. So what is it going to? So it is going to take up the call from the get volt and it is going to return new volt. So it is going to return new volt. So how the return has come? So new volt. So what it is now? It is now V3. It is now stored in V3. So now V3, so what we are saying, V3 dot get volt. So V3 dot get volt. So now basically, okay, let me again show you what exactly is happening. So we are using new socket class adapter implementation. So once this is initialized, so who is initialized basically? So once it is initialized, so this is initialized. So this is initialized in the sense, so what happens? This is initialized in the sense what happens? So we are making a, so we are making a call to the get volt. So we're making a call to the get volt. So get volt. So where is that get volt here? So get volt is, so get volt, what returns get volt? Get volt returns a new volt of 120. So where the new volt of 120 is? New volt of 120 is V3. Okay, so V3. So V3, V12. Okay, so V3, V12. So what it will give? It will give 3, 12, and 120. So V3 volts using class adapter, V3 dot get volts, V12 dot get volts, V2. Okay. So now once you are saying get volt, so what it is taking? It is taking socket adapter and I. So what is I? I is 3. So I is 3. So once we say 3, what it will do? So get 3 volt. Get 3 volt. So what is this get 3 volt? Get 3 volt is nothing but this. But this should be overridden somewhere, right? So where this is overridden? This is overridden here. So get 3 volts. So get 3 volt means what it will do? It will return. So it will return get 3 volt means what happens? Get 3 socket adapter. Get 3 volt means what will happen? So it will return. Exactly. So it will return the 3 values. So V comma 40. So V comma 40. So basically what happens? Okay, let us run this. So let me save everything here and let me run this and see. So you can see that. So what you can see, V3 using, so using what is written? So V3 dot get volts, what is the value that is written? So value that is written is 3. So value that is written is 3. Okay. And then 12 dot get volts, value that is written is 12. So 12, 120. So what basically happens here? So whenever you are going for get volts, so get 3 volt, get 12 volt and everything. So what exactly happens? So it will be converted. So for example, if we are taking up, so if we are taking up something like, so we are getting something like I value. So I value basically is like 10 or something. Okay, so 10 or something. So 40. So 120 by 40. So 120 by 40. So 120 by 40 is 3 volts. Okay. So next is 120 by, so 120 by 10. So 12 volts. So 120 by, so in this way, you are going to deal with, the conversion. So this is how we went for the socket adapter. So and then when we go for the same with when we go for the same with our when we go for the same with our object adapter. So the same kind of things. So what exactly happens? So now again you go for the adapter pattern and you say get volt sock adapter comma 3. So where the call is going? So the call is going here. So once the call is going here, so what is I value? I value is 3, let's say. So I value is 3. Okay, so I value is 3. So you can see here. So I value is 3. Okay, I value is 3. So what is happening? So here case 3. So case 3 return sock adapter dot get 3 volts. So get 3 volts sock adapter dot get 3 volts. So sock adapter is nothing but sock adapter is nothing but sock adapter is nothing but this one. So get 3 volt. So get 3 volt is implemented by whom? So get 3 volt is implemented by get 3 volt is implemented by this. Okay, sock dot get volt. So V by 40. So that is 120 by 40. So 120 by 40. So you are getting 3. So same thing. So in this way, you are able to access. So in this way, you are able to access the volts and you are able to convert. You are able to convert the. So you're able to convert the volts. Okay, you are able to convert the volts. At the end of the day, you are taking help of 5 classes. Okay, so this is the implementation basically. So this is the implementation of using inheritance and the composition. So you are using inheritance and the composition. Okay, so this is how we generally apply the concept of concept of adapter pattern under the concept of adapter pattern under the structural. Okay, so now if I'm talking about the next one, which is known as a bridge design pattern. So whenever I'm talking about bridge design pattern, so what exactly is bridge design pattern? It is nothing but decoupling. So decoupling the interfaces from implementation and hiding implementation from the client process. So it is like using the concept of abstraction. Okay. So using the concept of abstraction. So once again, I'm telling you, so don't get away from the concept of OOP. So here we are going for the abstraction. Okay. So according to the group of four. So design pattern is all about group of 4. Okay. So decouple an abstraction from its implementation so that the two can vary independently. So basically what we are trying to do, we are trying to create some interfaces and we are trying to have the codes of the shapes, interfaces and the classes from them. Okay, so that is what the main agenda. Okay, so but before going to that, so let us see the codes, what exactly are we have went for. So let me first show you. So instead of going directly to each and every class, so now let us go to the main call. Okay, bridge pattern test. So under this bridge pattern test, what you see here, you see a new triangle. So what exactly is triangle? New triangle with a new red color. So new triangle with new red color in the sense we are going to have a triangle class. So in the triangle class is extending the shape. So what is shape? So shape is a class, which is abstract class, of course, which has a protected variable color, which will be of the color type. So what exactly is color type then? So color type is an interface. Color type is an interface. Okay. So color type is an interface. So apply color. So this will be, so that will be kind of inherited. So that will be kind of inherited for every, so that will be kind of inherited for everything who will take up. So we'll take up the color as the parent. We'll take up the color as the parent. Okay. So now triangle extends shape. So triangle extends shape. So triangle is extending shape means, so what shape contains? Shape is containing color. So shape is containing a constructor called shape. Okay, shape is containing another abstract method called apply color. Another abstract method called apply color. Okay. So now going back to the main class, what exactly I'm doing here? I'm saying try dot apply color. So try dot apply color. So means to the triangle object, apply color. So try dot apply color. So what is this try dot apply color? So under the triangle, you are applying color. So triangle filled with which color? Color dot apply color. So color dot apply color. So color dot apply color in the sense. So what will happen here? So color dot apply color in the sense. So what will happen? So you can see the color, apply color. So you can see the green color. So now basically triangle. So triangle. So what triangle has to say? Triangle has to say apply color. So color dot apply color. So when somebody is saying triangle, so when somebody is saying triangle, so what exactly you see over here, which pattern? So triangle. So whenever the triangle is called, who should be called first of all? The constructor should be called. So in the constructor, what is there? In the constructor, we have a color C. So super of C. So super of C. So then what exactly this colors is? So this color is, so this is going to the shape. So this color is going to be, so shape. So shape color C. So this color is equal to C. So where is shape called up now? So shape is called up here. So what is it going to give? It is going to give new red color. So what is red color? So new red color. So here you can see color is red. Okay. So in this way, you are looking at the color. Okay. So simply, okay. So let me just run this and see the output, and then we'll again come back. Okay. So now triangle filled with color red and pentagon filled with color green. So what exactly is happening over here? So when you are making a new triangle call, where that call is going, that call is going to the new triangle. Okay, new triangle. Fine. So new triangle, what is it taking? It is taking color C, super of C. Means where the call is going, super of C means it is taking up to the parent class constructor. So what is parent class constructor? C. So what is this? This dot color is equal to C. So this dot color is equal to C. Fine. So now again, if you observe, okay, again, if you observe, so what we said? We said try dot apply color. So what is try dot apply color here? So try dot apply color. So when we say apply color, so triangle filled with color, so has come, and color dot apply color. So where is this color now? So this COLOR. So who is this COLOR? COLOR. So where is COLOR? COLOR is nothing but COLOR is nothing but, okay. So COLOR. So whenever we are trying to see the COLOR, okay, sorry. So what exactly is COLOR here? So apply color. So try dot apply color means where it is going? It is going to here. So triangle filled with, so COLOR. So basically you are looking at COLOR. So color. So what it is? COLOR dot apply color. So dot apply color. So when you say COLOR dot apply color, so what is it? It is going to go for this. So that is why it is red. And then if you go for the pentagon, so if you go for the pentagon, so once you see the pentagon over here, so where is the pentagon call? So here is the pentagon call. So new green color. So where is new green color going? So new green color is going to apply this. Okay, it is implementing green. Okay. So in this way, you can see that. Okay, so you can see that the bridge pattern is applied. So bridge pattern. So what exactly bridge pattern is going to tell us? Bridge pattern is going to tell us that, so we are decoupling. So we are decoupling. So decoupling the classes. So decoupling the classes. So in this way, you are going to work with the bridge pattern. So we are going to work with the bridge pattern. So in this, this style of decoupling the activity is known as the bridge pattern. Okay. So and then we are going to look at the composite design pattern. So what exactly is composite design pattern? So composite design pattern is also under the structural pattern, It is used when we have to represent the whole part hierarchy. So whole part hierarchy in the sense, whole part hierarchy in the sense. So let us understand. I understand by this simple example. So a simple example here is a diagram is a structure that consists of objects, okay, like circle, triangle, etc. When we fill drawing with color, the same color also gets applied to the objects in the drawing. Okay. So basically what I'm trying to say, if it is applied to one part, the other parts also will involve the same kind of object hierarchy. So that is what the pattern is. Okay. So that is what is design pattern. Okay. So create a structure in a way that objects has to be treated in the same way. So what exactly we are going to do? So we are going to say that, so we are going to apply the things on the whole, basically. Okay, right. So basically we have three important components under the composite pattern. One is the base component, one is the leaf, and the other is the component. So when I'm saying base component, so what exactly is base component? It is nothing but the interfaces for all the objects, in the composition. So defines the behavior for the elements in the composition. So it is a building block of the composition. Okay. So it consists of leaf elements and the implement that operation on the base component. So, okay. So importantly, base components, leaf, and the composite. So base component, leaf, and the composite. So whenever I'm talking about the base component, it is the interface of all the objects. It is the interface of all the objects in the composition. Okay, leaf defines the behavior for the elements in the composition. Composite means consists of leaf elements. So what exactly we are trying to say? Composite design pattern contains base components. So contains base component and okay. So let us understand by the help of the example, so that we can have a more clarity on it. Okay. So now let us go to the program directly. And if you see here, so everything I wrote at one place, so to make it easy and flexible. Okay. So now here you can see. So java.util.rl, so java.util.list, so interface shape. Okay, so public void draw. Okay, so what is the shape containing? Shape is containing only one method called draw. Okay, so triangle is implementing the shape. So implementing the shape in the sense, it is going to have this particular method, because interface. So if you remember the basic concept of interface, so interface means, so interface will contain a abstract method only, and those abstract methods are to be used by the child methods. Okay, I mean child classes. Okay, so now what you observe here? So you observe that you are having a circle that is also implementing the shape. It is also implementing the shape. So here you can say it's a hierarchical kind of relationship. So wherein triangle is implementing, wherein circle is implementing, whereas drawing also is implementing. Okay, it is something similar to our composition, so which we have seen. Okay, so basically what we are trying to do, so we are trying to have a list of shapes here. So those list of shapes, so what we are going to see here, so we are going to see the list of shapes here. Okay, so now exactly we go for the main method. And once you say main method, so what is happening here? So you can see a triangle being created here. Okay, so you are creating a triangle. Okay, so that triangle will make a call to the triangle class. Will make a call to the triangle class, right? So triangle class, as there is no constructor, we don't have to worry. So try1 and CAR are created, and we are adding those implementations. So we are adding those implementations to the list. So which list we are adding? We are adding up to the list of shapes. We are adding up to the list of shapes. So we are adding. Okay, so drawing new drawing. So under which So under which we are going to have shapes like array list. Okay, so shapes, so list. So and that list, so we are saying drawing dot draw red. So drawing, under drawing, you are drawing red. So this dot shape dot add of yes. What is S here? S is nothing but the red. This is nothing but the red. So in that way, you are going to work with the composite pattern. So you're going to work with the composite pattern. So composite pattern literally depends on the composition. Depends on the composition. So these are the things. So let me just run this and show you what exactly happens with the output. So what you are going to see here. So you are going to see. So drawing the triangle with red. So these are all the things that you will get as well. So this is how the composite pattern is coming into the picture. So coming into the picture. Okay. So now this is how we have developed the concepts of, so this is how we have developed the concept of the design pattern. So if you go back once again, so we are going to see the design patterns. Okay. So let me show you the structural design patterns. What are they? Adapter pattern, bridge pattern, composite pattern, proxy pattern. So we are not interested in proxy, flyweight, facade, and decorator, but we have seen these three patterns. Okay. So in the next session, we will be looking at some behavioral patterns. So we are done with the creational patterns. We are done with the structural patterns. So we are going to look at the behavioral patterns in our next segment. Okay, so meanwhile, so you can see that adapter design pattern is all about two unrelated interfaces, making two unrelated interfaces to work together. Okay, so what basically happens here, objects are created which are going to connect the two unrelated interfaces. Okay, greatest example is a mobile battery. Okay, so where we are creating multiple classes, unrelated classes, and combining them. Okay, so to get the job. Okay, so two-way adapter pattern basically works on two particular approaches: class adapter approach and object adapter approach. Where class adapter approach is going to use the inheritance concept, and object adapter approach is going to use the composition. Okay, so and we are also going to understand, we also understood rather, so bridge design pattern, under which we are going to decouple. So we are going to decouple the classes, so making use of the instruction literally. Okay, and then we have went through the concept of triangle, color, pentagon. So like triangle is a class which is going to be taken up from shape. Okay, so many things we have understood. So under the composite design pattern again, so we have used like one change happens in one place, so the whole hierarchy will get that change. So that kind of pattern that we have seen. So this is the composite pattern on the whole. Okay, on the whole, it will make the changes. So whenever you are trying to, go for the composite design pattern, so you are going to use the concept of a composition. So composition basically is a hierarchical relationship. Sorry, has a relationship. So hierarchical relationship is like is a relationship. So composition, aggregation are the other names for the has a relationship, where is a relationship is a inheritance relationship. So these are the things for today. So hopefully everyone is okay with the things. Okay, so these are the things. In our next segment, we will be looking at next and the last segment, I should say, last segment of the design patterns, where we are going to look at some behavioral patterns. Okay, so behavioral patterns, which will include some of the design patterns, very interesting design patterns. So that we will be seeing in our next. Okay, thank you everyone for joining, and thank you for your patience. Thank you so much. So hope you got a lot of things out of this. Okay, thank you so much. Thank you. Bye everyone. Have a great one. Thank you.